we will see how the CTC works in a nutshell. So in a nutshell, we already know that we need not to annotate the images at each horizontal position, which we call timestamp or stamp from now onwards. The neural network training will be guided by CTC loss function. So whatever we have got till here, this thing will be guided. The training of these all things and this matrix will be guided by CTC loss function and optimizer, as I said, SGD or any optimizer or any Adams optimizer loss function, any gradient descent you can use. So we will process everything from this matrix only. We want just this matrix, character versus timestamp, that will be the input to the CTC, and from there onwards all the process will be carried forwarded. And also we also need ground truth values to compare the results, because we need the ground. This is again supervised learning, so we need some information, some heuristic in terms like we have data set, so we can just give ground truth values. And again, it's not H, character level, word level, it's not like that. It will be to complete hello, complete text. So we want this matrix and we want ground truth values, so we will feed that to CTC module here, and that will do some processing, and that will train the model. And then again, once we will after training the model, once we will send the test image or validation image, we'll create again the matrix, or it will compare with the trained matrix or weights, and then it will give the prediction of text from the image. So hand text image is converted to simple plain text. There is a whole purpose of the AirSketch or the whole hand text recognition system. So as I've said, we only feed the output matrix on neural network, this thing, and the corresponding ground truth value to the CTC module, CTC loss function. But main thing is, how does it know where each character occurs? So it doesn't know, right? So well, it doesn't know. Instead, it tries all the possible alignments of the ground truth value. So it doesn't know like whether H is occurred in first timestamp, or it is occurred in half H is occurred over here, or it is occurred in here, because it just have ground truth value. So what it tries is, whatever it goes using that matrix, it will try all the alignments. So we have here characters and here timestamp, right? So it's something like this. So it will try first letter, at first timestamp the letter can be H for suppose, and at the second timestamp it is E, because here it is H, E, for example I'm telling. Then again next timestamp it can be again E, maybe the E is widespread. Next timestamp it is L for suppose, and again two L's are there, and next timestamp it is O. So this is actually the main thing, like, or the ground truth value we have predicted actually. And again two E's are there, we need to like do some processing. But again, this is an optimal case where we are getting the right answer. So yeah, so instead it tries all the possible elements of the ground truth text in the image and takes the sum of the scores. This way the score of the ground truth text is high if the sum over the alignment scores has a high value. So we can take any heuristic or any metric like this alignment is highest, so we can just check that with the ground truth value, and if the loss is less and the accuracy is more, we can take that, or sum of all the alignments we can take. The sum of scores is nothing but probability scores. So this way it works. So for example, so in a nutshell, tries all possible alignments is a way to go. So we'll see encoding the text, loss calculation, decoding. So sequence for that we will just require a little bit of basic or pre-knowledge. Is like the sequence to sequence modeling. For example, whatever the voice or hand text we are going to hand text, for example, sequence to sequence modeling we are giving, it is giving I am good. And again, it's some different language, it's English, for example it's French for suppose. So input will be X, we have N of length, and this will be M for suppose. So in this like translation or anything, here we can see that N is not equal to M, because in English 3 words, for example in French it can be 4 or less also, so they are not equal. And no synchrony, like am can be first, could can be in middle, and I can be last. So there is no strict alignment that this should be English to French mapping should be same. So that's what we are going to talk, like in sequence to sequence those things will happen. So first we'll talk about encoding and decoding, how to encode a duplicate character. So for example, we have two, we can use simply blank. Like if this is a text, we can just use simple blank. It's like a hyphen, not underscore, anything you can take. It's not like regular blank of the dictionary term, it is special blanks so that processing can be easy. So what this does is it separates out. For example, what happens is, if they are continuously occurring, we can take this as single term 2 and t, and this we can take as o, and we can just ignore these things. So it is denoting 2. And here also we can just remove this is one term and space other term, so to. So it's giving like a divider thing. So whatever over here, take only once, and whatever over here, take only once, and this thing is nothing but blank divider, something like that. If you want to represent 2, the different alignments can be, so these can be like ignored, and this completely should be taken as 1, and this thing, because these are duplicates, and again once, what I have said over here is once over here 1, that is nothing but same element should be taken once, duplicate should be avoided. And here we have 1 o, so it will be t o blank, so here we have just 1 o, so it will be 2, and here this can be ignored. Once t appearing, then again blank, here once it is appeared, again blank, o is appear again, and this we can ignore, so 2. And this also, so as you can see to, so no duplicate, so directly we can take to and blank, and once o is occurring, so 2. So these are different alignments for the same text. So this is how we can do. And again, one more example I can give, hel blank o, this hel blank lo, so hel blank is there, so we can just write again l, this we can take. And if we have something like this, he blank ll, this thing we can take, this thing, this we can ignore, he, and then we can take ll, so we can't take ll because these are duplicates. Only once we have to take blank and o, so it will be helo, right? So encoding, decoding, so this is encoding. Actually for this term we are encoding this, and decoding will be ignore this, and this thing's duplicated, so only once we can take, and this thing only once we can take, so this is decoding. So we can encode the same in different alignments like this, encoded alignment, and we can decode it further to to.